Hey guys, it's Tanya Mitchell from TRIO Student Support Services here at Rose State College. And for today's video, we're going to be talking about Chapter 7, which is chemical reactions. Some of the terms that you need to pay attention to and be able to identify and define are the types of reactions that we're going to be talking about. So we have gas evolution reactions, combustion reactions, which include oxidation, reduction reactions, precipitation reactions. So we witness chemical reactions on a daily basis. So some of the things that we witness as far as chemical reactions are color changes, like when you have a piece of metal that rusts. You see color changes in the lab when you do precipitation reactions, and you'll probably have a lab coming up doing those. When you see the emission of light, when light is emitted from a substance or an object, that's a chemical reaction. The formation of a solid in a previously unformed or clear, unclouded solution. The absorption of heat. So you know those ice packs that you get at Walmart or Walgreens and you have to break the core. That is a chemical reaction. The formation of a gas when we add a substance to a solution. So like when you are boiling water, it's emitting steam, so it's kind of evaporating, so that's an evaporation reaction. So a lot of, like I said, we witness chemical reactions on a daily basis. So these are the ones that you need to be able to identify and define, and we're going to talk about them in more detail later on in this video. But the first thing that we want to talk about is the chemical equation. And let me just put an example of a chemical equation up here on the board for you. And this one comes straight from the textbook. Alright, so this is a chemical equation. Alright, so on the left-hand side of the equation we have our reactants. And then on the right-hand side of the equation we have the products. So this is an equation for a reaction between natural gas and oxygen. And when these two react, they produce carbon dioxide and water. So this is an example of a chemical equation. And what we're going to learn is how to balance these equations. But before we can do that, we need to be able to identify the different states of each compound in this equation. So when you are writing out equations, you need to be able to identify gases, which is a G. So G is for gas, L is for liquid, S is for solid, and AQ is for aqueous. So aqueous is a solution in water. Okay, so that's aqueous. All right, so we are going to balance chemical equations today. Okay guys, so balancing chemical equations. There's no special trick to this. This is just the way that I do it. So I make a table, and your professor may show you this method as well. But I make a table with products on one side and reactants on the other. So I look at the product side, and I make a list of each element. Right, so I have carbon, hydrogen, and oxygen. And then I look at the number of molecules of carbon. So I have 1 molecule of carbon, 4 molecules of hydrogen, and 2 molecules of oxygen. And then I go to my reactant side and I do the same thing. So I go to my carbon. So my carbon is just going to transfer over from here I have 1 molecule of carbon. My oxygen, so I have 2 molecules of oxygen in my CO2, and I have 1 molecule of oxygen in my H2O. So that's going to give me a total of 3. And then, whoops, right? So 3 oxygens, and then I look at my hydrogen, and I have 2 hydrogens. So the whole point of balancing equations is to make sure that there are the same number of molecules on the product side that we have on the reactant side, okay? So the first thing that we're going to do is we're going to balance our oxygen atoms. So we have 2 molecules of oxygen on the product side. We need to match that up to the reactant side. But 2 and 3, we would have to find a common denominator, kind of like in fractions, so that we could balance this out, right? So we're just going to skip oxygen for now, and we're going to go to hydrogen. So on our product side, we have 4 hydrogen, and on a reactant side, we only have 2. So what we can do is we can add a coefficient. So if we add a coefficient to our hydrogen, then that'll give us 4 hydrogens, but then that changes the number of oxygens that we have. So we have 1 oxygen times 2 plus 2, so that gives us 4, right? So then we can just come right here and we can add a 2 coefficient to our oxygen. So 2 times 2 is 4. So our hydrogens, our oxygens, and our carbons are balanced. So this is a balanced chemical equation. Balancing these equations can get a little tedious, especially if it's an equation that has a large number of molecules on the product side and the reactant side. So let's take a look at a couple more and we'll practice those together. So we have this equation here, which is a silicon dioxide and a carbon, and they combine and create these substances over here: carbon monoxide gas and a silicon carbide solid. And so first thing that we want to do is we want to do our table, and we want to identify our elements: silicon, oxygen, and carbon. And looking at our reactant side, let's take inventory here. So we have 1 silicone on the reactant side and 1 silicone on the product side. Now looking at our oxygen, we have 2 oxygen on our reactant side and only 1 on the product side. And then we have 1 carbon. But we go to our product side and we have a carbon here and a carbon here. Okay? So, all right, now that we've evaluated, what we need to do now is we need to start balancing our elements, okay? So we'll start with our silicone. Our silicone is already balanced, okay? So we can just put a check mark next to that. Our oxygen, so if we look at our oxygen, we've got 2 oxygen atoms on the reactant side and 1 oxygen atom on the product side. So the best thing for us to do would be to put a coefficient in front of the carbon monoxide. So that will balance our oxygens. But then it changes our number of carbons, okay? So we go from 2 carbons to 4 carbons, right? Or 3 carbons, excuse me. Because we have 1 carbon here and 2 carbons there. So now we have 3 carbons, okay? So in order to balance our carbons, what we need to do is we need to put a 3 coefficient in front of the lone carbon on the reactant side. And now we have a balanced chemical equation. Occasionally, your professor is going to give you an equation in written form. This is a good example. So what this question says, it says to write a balanced chemical equation for the combustion reaction of gaseous C4H10 and gaseous oxygen to form gaseous carbon dioxide and gaseous water. So the first thing that you have to do when you're given a written equation like this is to identify your elements, right? So the best thing for you to do is to just underline, right? So we have a gaseous C4H10, we have a gaseous oxygen, a gaseous carbon dioxide, and a gaseous water, okay? So knowing what we know, okay, we are going to put our chemical equation on the board, and it's going to look something like this. So it's going to be C4H10, and it's gaseous. And we're going to add that to oxygen, and that's a gaseous oxygen, and it's going to form or yield a gaseous carbon dioxide and a gaseous water, okay? Water, H2O. All right, so this is what your equation should look like. Now this is before we've done any balancing, okay? This is just the information that we gathered from the written example here. So what we need to do now is we need to identify all the parts of the equation and inventory the number of molecules that we have for each of the parts, and then balance it from there. Looking at our reactant side, we have carbon, and we have 4 molecules of carbon. We have 10 molecules of hydrogen, and we have 2 molecules of oxygen. Now when we look at our product side, we have 1 carbon, 3 oxygen, and 2 hydrogens. Okay? So we need to balance this, and what we're going to do is we're going to start with balancing our carbon atoms. So what we're going to do is we're going to add a 4 coefficient here. So that changes this carbon to 4, and it matches this carbon here. Okay? Then the next thing that we're going to do is we're going to look at our hydrogen. So on the reactant side we have 10 hydrogen, and on the product side we have 2 hydrogen. Okay? So the best thing for us to do is to add a 5 coefficient to our hydrogen here. Okay? Because the 5 times 2 equals 10. Alright? Now, looking at our oxygen. So I intentionally saved these oxygens for last. Because if you look, you have 2 oxygens on your reactant side, but now that we've added all these coefficients, our number of oxygens on our product side has changed. So we can no longer say that we have 3 oxygens, right? We have 4 times 2 is 8, plus 5. So that gives us 13 oxygens. Okay? Now, there's not an even number that we could put in front of the oxygen to multiply by 2 to give us 13. So what we have to do is we have to take the number of molecules that we want on our product side, and we have to put it in front of the oxygen. But we want to put it over a denominator of 2, okay? Because we have 2 oxygens here, so this denominator needs to match. And then what we're going to do is we're going to take this entire equation, we're going to multiply it by 2. And when we do that, it gives us an altogether new equation, right? So the new equation looks like this. So basically, we just took this 2 and multiplied it by every coefficient of every compound in this equation. As you can see, I did not multiply the 2 by the 13 because when you look at it, this is 2 over 1. So this canceled out, and that just made it 13 over 1. Okay? So if we look at this again, we can actually say that this is a balanced chemical equation. We have the same number of molecules on the reactant side as we do on the product side. If I'm not mistaken, there are a couple of these problems that are going to be on your exam. Maybe not your quiz for Chapter 7, but definitely on the exam. And if you look in your textbook at problems 35, 36, 37, and 38. There are some more problems like this in your textbook. So you may also have some on the homework page that your professor assigns. So that is balancing chemical equations. Guys, so your professor is going to lecture you about the different chemical reactions and how to identify the substances in the chemical reactions. One thing that they're going to talk about is the solubility rules. And so the solubility rules it has a list of items or a list of elements, and it says that when this element combines with this substance, then it will either be soluble or insoluble. And so you've got to be able to read the solubility rules table in order to identify some of these substances, right? So this is in your textbook. There is a nice diagram, a nice flow chart on page 218, and then the solubility table on 219, right? So what I wanted to do, what I wanted to do is I wanted to put a few substances up here, and if you could look along with me on your solubility table, and we can determine if these substances are soluble or insoluble, right? So just checking our solubility table, sulfur. So there are no exceptions for sulfur and copper. So when we look at the solubility table, we can actually say that this is an insoluble compound, right? So now let's look at iron and sulfate. So when these two substances combine, so when from your solubility table, so when SO4 pairs with calcium, strontium, barium, or lead, the compound is insoluble. Okay, so the iron does not fit into that category, so this is going to be a soluble compound. Now looking at our lead carbonate, let's see, down here at the bottom in section 2, we have our carbonate, and it says when either of these ions pairs with lithium, sodium, potassium, or ammonium, the compound is soluble. So our lead carbonate is going to be insoluble. And then we have our ammonium chloride, which ammonium is on our list. Actually, chloride is on our list, is it not? Yes. So it's going to be in the top section. Chlorine pairs with silver, mercury, or lead. The compound is insoluble. This is not lead, so this is going to be a soluble substance. Okay? So I just wanted to show you very quickly on the solubility rules. Your professor is going to go over it in more detail, but as you are putting your compounds together and writing your equations, you're going to have to identify these. Okay guys, so we're going to write an equation for a precipitation reaction that occurs, if there's any reaction at all, when solutions of potassium hydroxide and nickel 2 bromide are combined. Okay, so when these two reactants come together, what do they produce? Okay, so the first thing that we need to do is we need to identify our substances. So our substances here are, let me do this with a different color. So our substances are the potassium hydroxide and the nickel 2 bromide. Okay, so checking our solubility chart, let's see, we need to determine if either one of these are potentially insoluble based on our solubility chart. And so when I look at my solubility chart, I see that my potassium, or when these two substances come together, my equation is going to look like this. So I have my potassium hydroxide Okay, so now we need to determine when these guys switch partners, what is going to be our outcome, right? So our first element here, this is our cation, and this is our anion. Cation, anion, okay? So with a precipitation reaction, our first cation is going to swap partners. This is going to become potassium bromide and nickel hydroxide, right? But we need to determine if either of these substances are insoluble. So we'll know how to complete our chemical equation, right? So just looking here, our nickel is insoluble. Our nickel hydroxide is insoluble. Okay, so when we finish this out, this is actually going to be a solid, right? So then it looks like this. So we have our nickel hydroxide. Our calcium bromine, potassium bromine. All right, so then what we have to do is we have to balance the equation, right? So just looking at the reactant side and the product side, what do we need to do in order to balance this equation? So we have one nickel, 2 hydroxides. So we're going to have to two bromides. So we're going to put a 2 here and a 2 here and call it a balanced equation.